and the next condition is that the concrete strength should be more than 28 megapascal. The concrete strength should be more than Fc prime should be greater than or equal to 28 megapascal. Okay. Next condition, that is the presence of overhang on both sides. There should be overhang between the both sides of the bridges. This part of the bridge is known as overhang, this part. So there should be an overhang on the both sides of the bridge, and this overhang should be greater than 5 times the depth of slab. Or, now this depth is greater, so 3 times this depth. 5 times the depth of slab, or the 3 times depth of slab with barrier. The depth of slab with barrier. If there is a barrier or there is a footpath, so this length should be greater than 5 times 5 times depth of slab. What is the reason for this?
So does it depict like this? Can resist the other side.
It is just like balancing. For example, if you see, it is balancing the bridge on both sides. If you provide a girder here, what will happen if the wheel load is here? It will try to bend. The bridge will try to bend. So in order to avoid such condition, they have imposed this criteria that this length should be greater than 5 times h, where h is the depth of slab. Okay, if these conditions are satisfied, then we can use what? This steel reinforcement. And you know, the bridge layout, when we decide the bridge layout, you know, bridge layout means where to place the girder, where to put the barrier, how many number of lanes, the size of footpath, the size of curb. When we decide all these things, then that time we can see these conditions. So what we have to do, we will decide the layout of the bridge and then we will check these conditions. I hope that in most of the cases these conditions are satisfied. In most of the cases you will see that. Well, for example, in most I tell you that an economical bridge design have this spacing from 1.5 to 3 meter. You have seen the girders. How much is the spacing between the girders of the bridge when you go around?
About 1.5 meter. About
2 meter, yeah, 2 meter or 2.5 meter, maximum 2.5 meter. But because if you increase this spacing, the deflection or the slab will become more thicker. And if you increase the number of girders, it means you are providing the support to the bridge slab. And yes.
What about if we increase the size and increase the size as well? Size of gear.
You mean provide less girders but with bigger size?
Yeah.
You know these girders. If you increase this spacing, this part will become heavier. The slab will become heavier, and the load on the girder will also become
heavier.
more.
It's not distributed.
So there is an interaction which you have to think. For example, you should not provide like so many girders, like girder after every 1 meter or girder after every 0.9 meter. It doesn't make any sense. Did you understand my point? So there is an interaction which you have to work out, but the reasonable or the good figure is from 1.5 meter to 3 meter. Agree? Okay. So this is the design of slab. Was it difficult?
Until now, no.
Takes time.
So what we have to do, we have to design the bridge layout, and then, but this method is known as empirical method. If all these conditions I have just explained to you, if all these conditions are satisfied, then we can use that steel. We don't have to do anything. Use that steel, but still you have to check with the distribution steel. Still you have to check the distribution, AS minimum for distribution steel, which we have already calculated. That was, I think, 1750 divided by square root of S, less than or equal to 50%. For example, if the distribution steel, I'll tell you once we will do that. There are two equations, one for the reinforcement parallel to the traffic and the distribution steel perpendicular to the traffic. In that case, in this case, the main steel of the slab, it will be perpendicular to the traffic or parallel to the traffic. In this case, the slab main steel, it will be placed in this direction. In this direction or in the outer plane, this way.
No, in the other direction.
Like this?
Yes, I think.
No.
I
No.
think, yeah.
This way?
Yeah.
This main bar will be.
And what about the girder steel? The girder steel will be like this or like this?
No, for sure, like this.
For sure like this. Then what about the slab?
The opposite.
The opposite, I think.
It should be, now the slab is supported by the girders.
Yeah.
And what is the span? Now in this case, this is not the span, this is the span of the girder. Before, we don't have any girder. In that case, this was the span of the slab. But now in this case, the slab span is the spacing of the girders. Okay? So we have to check how much is the span, and we have to place the steel in this direction, in the horizontal direction, like this.
The maximum span for the slab will be about 3 meters.
You can say, it depends upon how you are going to decide the layout of your bridge. So this is what all about the slab design and the steel. So in that case, the steel is perpendicular to the traffic or parallel to the traffic?
Perpendicular.
Perpendicular. So we have different equation for distribution steel. But before, in case of slab bridge, we did not have any girder. So the steel was parallel to the traffic or
Parallel.
perpendicular to the traffic?
It was parallel.
The main steel, the primary steel, it was parallel to the traffic. So we had a different equation. Now let's talk about, so we have done with the slab. Now come to the girder. Let's talk about the girder. This stuff. You know, like slab bridge design, we had two types of strips. We had exterior strip, we had interior strip. Similarly, now we have two types of girders. The one is exterior girder and other is interior girder. But now we have two types of distribution of the load. This is very important point. Now we have how many types of distribution of load? Two types. Now what are those two distributions? For example, what do you think? Let's talk about this interior girder. What do you think? When the wheel will be like this, then this is the axle, and the axle load is 145 for the back axle. Do you remember? If you remember the truck had three axles.
Yes.
Yes.
35, 145, 145. So this is 145 axle. This axle has two wheel loads.
Yes.
Now, how much of 145 is going to this girder and how much of 145 is going to this girder? Did you understand that?
Yes.
And what if the truck moves a little bit this side? Do you understand or not?
Yes, yes.
So there are two types of distribution, two types of things are happening. For example, this is the length, a beam. This is the span of the girder. This is the total length of the girder, say, whatever you say, like span of the bridge. So, if your truck is passing, so what is happening? the bending moment is changing as the truck is moving on the girder along the length. So this is known as longitudinal distribution. And what is this? When the truck is moving across the girder, so the force on this girder is changing. And this distribution is known as transverse distribution. So in case of, yes?
Victor, can we find it by the absolute, by doing influence line for the girder?
That is for the longitudinal. Influence line diagram is for the longitudinal distribution along the length. You have the length of beam and then you draw the influence line diagram or function and you put the truck over that. But what? This is a longitudinal distribution. But now see, the truck, this is a girder. Now the truck can go this way, the truck can go this way. But which way the truck will have the maximum effect? Did you understand?
Yeah.
So this distribution is known as transverse distribution. We call this P. Let's call this P. Okay? So we have to find, we have to think, we have to decide how much P is coming on this girder. Is it the full P? It can happen. The full P is coming on this girder.
No, cannot be happen.
It can happen that this P is 0.5, this load is 0.5 P.
Yes.
Yes, it can happen. It can happen this could be 0.8 or 0.9 P.
Yes.
It can happen, yes. So we have to find this value. How much of this total load is coming on this girder? Okay? And then, for example, if you see this is 0.9 P or 0.7 P, for example, so you can just put it here 0.7 P, 0.7 P, and 0.7 into. So you multiply 145 by 0.7, you multiply 145 by 0.7, and you get this load, and then you have the influence line diagram, and then you can find out the maximum bending moment and maximum shear force. So in case of bridge girders, we have two types of distribution. One is transverse distribution. Transverse distribution is what? To find the share of this axle load to a girder. How much is coming to this girder? And similarly, if this truck goes this way, how much is the share of the exterior girder? So we have to find the transverse distribution. Once we have this function 0.9, 0.5, whatever, then we can just put this value over here and we can find out the maximum shear force and bending moment as we have done in the case of slab bridge. Any question? Because now I'm going to tell you how you can do this transverse distribution. Longitudinal distribution you already know, so I have to teach you the transverse distribution. Any question? This is your time.
It will be a question.
Okay, so let's talk about how to do the transverse distribution or the lateral distribution. Now I'm going to erase all this stuff, but you know what we are going to study now. So transverse or lateral distribution there are two types of girder. First, let's talk about for interior or for exterior. Let's talk about for interior girder. For let's talk about for interior girder. Number one, lever rule. I tell you that what is a lever rule? Lever rule, I think I have told you. So there is a distribution factor. Distribution factor G. Number one, for one lane loaded. For if a bridge is loaded with the one lane, then we can find G by there is a formula, and that is 0.4, and this G value is different for bending moment and for shear force. This G value is different for bending moment and for shear force. What is G? G is that component. G is like 0.7, G is like 0.6, 0.5. That factor which I told you 0.5p or 0.7p. So that 0.7 is basically G. Okay, that factor is basically G. For moment, it is equal to 0.06 plus S over 4300 into S over L then kg over LTS cube. .1. Yes. Now what is this S? What is L? What is kg? And what is TS? Now first of all, what is S?
Span.
Yeah, you're right. S is the span of what?
Of the between the girders.
Center to center.
Spacing of the girders. S is the span of the slab. The spacing of the girders. S is what? The spacing of the
Girder.
For example, like 1.5 meter, like 2.5 meter. It is not the span of the bridge, no. What is L?
L is the effective length. The effective length.
This is a bigger L. This is the span of the girder or the span of the bridge. What is L? L is the span of the bridge. And what is S? S is the spacing of the girders. What is kg? What is kg? Kg is a stiffness parameter. I think it's very early to tell you about the stiffness parameter, and it depends upon the moment of inertia and the eccentricity of that. For example, I can tell you the equation, but kg is equal to n into I plus. This is like moment of inertia, and what is n? N is the modular ratio. And modular ratio is what? For example, modular ratio for concrete is the ratio of ES over EC. ES is the modulus of elasticity of the steel and EC is the modulus of elasticity of the concrete. But you know, this TS is the thickness of slab. TS is the depth of concrete slab or the thickness of slab. This parameter kg over LTS cube, it is a parameter, and you know what? You can consider this parameter equal to 1. Or there is a fixed value which is given. I will tell you that value. In most of the cases, this kg over LTS cube, it changes somewhere from 1.5 to 2, and if you consider the 1, it will be a conservative value. If you consider this value 1, it is most of the cases it is less than 1. In most of the cases this value is less than 1. How much is this value given in the code? This trying to explore. So the ratio of kg over LTS cube, in most of the cases this value is less than 1, but for safe and economical design you can consider this value equal to 1. Because if this value is more than, if it is less than 1, then what will happen? Can you tell me? If this is less than 1, then what will happen? In most of the cases, this value is less than 1. Okay? It is actually the ratio of stiffness of bridge and slab. If this value is less than 1, what will happen to G? Tell me. G will be higher or smaller?
Higher.
If it is less than 1, G will be higher or smaller? Smaller. If this is less than 1, G will be smaller. So what we are going to do, we will consider the small load on the bridge, because this G will be multiplied by the axle load. So always this value is less than 1. So what is the safest value? If we consider equal to 1, is it the safe? Yes.
Yeah, it will be the same.
So in most of the cases we will consider this equal to 1. So if it is equal to 1, you have just these two parameters. The rest is very simple. For shear, G is equal to 0.26 plus S over 7600. This is for shear. Okay. Now, for one lane loaded, we have to also find out G by lever rule. G by lever rule. What is lever rule? Lever rule, I told you that for example, this is your, okay, so according to the lever rule, you will consider the reaction here, and you will take a moment here. For example, if the load is here, the wheel is here, P by 2, you will take moment at this point and you will find out this reaction. Okay? And from here you will get, for example, R is equal to how much P? R is equal to some value into P. So this value maybe 0.7, 0.6, 0.5, you will find it by the lever rule. When I will explain you this when we will solve the problem. Okay, so don't worry, this is very easy part. This is the most easiest part, the lever rule. Okay, nothing new. So this is how we will find the 2G value, 1G value by this equation and 1G value by this lever rule, and we will use the greater of these two for one lane loaded. Okay, this is for interior girder. Now let's talk about two lane loaded for interior girder. Two lane loaded. Number 2, for 2 lanes loaded. In that case, G will be equal to 0.075 for moment, 0.075 plus S over 2900 this is L, and then kg over LTS cube .1, and for shear G is equal to 0.075 0.2 plus minus one zero square. So this is how we find that factor for the lateral distribution. This is how we will find that factor for the lateral distribution for interior girder. Now for the exterior girder, again it's very easy. I'm going to erase, is it fine? Now for the exterior girder, for 1 lane loaded, G is equal to by lever rule. For moment, for shear, we'll find G by lever rule. Simple. And for more than 2 lanes, the G will be equal to E into G interior. For moment, for shear, G will be equal to E into G interior for shear. Now what is E? In this case, the first case, E is equal to 0.77 plus